Welcome to IT Pro TV. I'm your host, Don.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
Hello, welcome back to another exciting edition of IT Pro TV. I'm your host, Vaughn Smith, and this is our Cisco Cloud Fundamentals exam series. And right now we are going to look at block access storage. And here to help us is Mr. Ronnie Wong. Hi.
Hi, how are you doing?
Good, how are you?
I'm doing well, Vaughn. Thank you again for joining me as we continue to move forward here through our Cloud Fundamentals series. And you're right, we are up to this point where we need to divide out the idea of what we mean by block storage access. And so when we actually get started here, we've already talked a little bit about this in terms of introducing the ideas of NASs and SANs. And then we're actually going to now move into the realm and make sure that we can differentiate, of course, between block storage and, of course, even file storage. But we're going to spend our time talking about the block storage technologies first. The reason why is that we're most familiar with this, if we've come from the world of PC support, desktop support. The idea of actually accessing and removing hard drives and replacing them is pretty much the key of what we're actually doing here. But then we're going to move into the more complicated technologies to make sure that you have a fundamental understanding of that as we move through. So you'll see that we'll spend the majority of our time talking about the ideas here of SCSI technology. I know it sounds funny, but it's true. Okay, SCSI technology, and of course, well, your favorite and mine, the idea of fiber channel technology. I know it sounds funny and delicious and dietary at the same time, but it is not that. But we do need to make sure that we cover that as well. Okay, so Vaughn, that is what is on the plate for us. So it sounds like we are ready to get started. So let's go ahead and take a look at this idea here when we start talking about block storage. Well, this is what we are most familiar with, even though we haven't been calling it block storage before. Some of the actual technology, when we start talking about the idea of block storage, are things that we're most familiar with, okay? So when we start talking about the idea of block storage, this essentially is where systems are directly accessing, okay, and controlling the entire blocks of data that we have access to. So we're not really talking about the idea of individual files here, okay, but we're saying here is the chunk of volume of space that you have access to. And traditionally, in terms of a regular desktop computer, it's in the form of a hard drive of some sort. Okay, today we even go to solid state, but overall, though, it's in the form of a hard drive, is what we mean. So the neat thing is, when we actually get to this point, we don't have to even worry about whether it's actually on a single hard drive or it's actually across multiple hard drives. Okay, so for us, though, what it means is that the end user's system, okay, regardless of where it actually resides or anything else, what they see looks like to them a single, not operating system, a single hard drive. And that's the same thing with the operating system. It sees it as just another volume that it can access and get storage to. It doesn't care if it actually does reside, let's say, across a stripe in a RAID array. It doesn't care if it's on a NAS somewhere. It sees it as being just another hard drive that you are connected to. Okay. Now, this actually harkens way back to the earliest days of course, regular desktop computers, where the connection was done something like this. Now, there was no way for me to draw this internally in the computer, so I actually took it out of the computer here, Vaughn. But so here, of course, the cylinder represents, well, a hard drive for us. And the way that we connected that internally inside of our desktop machines is that we had what we call a ribbon cable. Vaughn, remember the idea of a ribbon cables?
Dude, it usually was very rainbow-like.
Yeah.
It had lots of colors.
Yeah, some of them really did. And so this one here, right, it actually had just a lot of different pins across it, and it was, again, smashed down into this ribbon cable, okay? And so when you connected that to the actual controller on the motherboard itself, it allowed you to gain access to a hard drive. Now, the earliest standard that we have is one that's called ATA, is the standard here, but it ended up dividing up. Sometimes you heard it called EIDE, IDE. It doesn't really matter so much today, the technicality behind which particular implementation or flavor that it is, but just kind of realize that the original one that probably most people are familiar with is what we'd call IDE type of storage. Okay. Now, with this one, it was limited in its particular expansion ability to a point. So you could have a maximum of 4 different drives, because normally most of the actual desktop computers ended up having 2 drive controllers on the motherboard itself that you could access. So it just really depended on what you needed to do. So it could allow you to connect up to 2 ribbon cables. Now, if you bought a pre-made computer, you probably didn't actually end up having 4 actual hard drives in it. You probably ended up having 1 in it, and the other ribbon cable you had to buy if you wanted to add in more if you did something like this. Okay. Now, when you actually had this here, the way that this ended up working out is that even with 1 cable, you could have up to 2 different hard drives on that single cable because there were actually 2 connectors on each ribbon cable. One was considered a primary and the other one was considered secondary. Now, I write it in this particular terminology today, Vaughn, because that's what's the acceptable terminology today. But when we first actually talked about it, it was actually termed as master and slave in the technology here. So you had a master hard drive, and then you had a slave hard drive. Okay, so that idea, of course, along with the realm of politics, right? It is actually even affected into the realm of computer and IT technology that we can't even call it what it originally was called here, which was the master and slave technology. So that's why you actually see the term on my screen here as being primary and secondary. Okay, you always had to have at least a primary drive, and you could configure that and say what that was what it was. And the way that you configure that is on the actual individual disks themselves. There was a little jumper that you could actually move that would actually allow you to set this as primary or the secondary disk, and you could do that as well. Some of the other later computers even also did it according to the space on the, I shouldn't say later, other computers did it based on which connector it was on the ribbon cable as well. So you could have a max of 4 drives, Vaughn, is what you could have on this type of computer system. Okay. Now, that was good, but it was relatively slow. And the reason why is that even with the ribbon cable, you were accessing either one drive or the other drive. You weren't accessing them both simultaneously. It just gave you the ability to actually switch between them to do what you needed to. So it was relatively slow, and the ribbon cable itself had a lot of interference issues. If you ever had one of these and you looked inside your computer, you kind of ended up seeing that your ribbon cable was pretty knotted up. Okay, as you actually took it out, it kind of was like mangled, looked almost mangled and twisted and stuff like that. It also made apparently a great antenna for additional interference. So whatever maximum speed you probably had is probably not what it was designed to do. But because there were so many different little pins in them, it's like 40 if I remember right, 40 different pins in the connectors that you had between the drive and the controller itself, it actually allowed for crosstalk that would also slow down the information on your system too. Okay, so the more devices that you have inside, the more electromagnetic energy, the more bleed over or crosstalk that you would end up getting. So even though these drives actually did work effectively, heck, from the time I owned a computer, probably up into, really, I'm saying I shouldn't say too recently, last 10 to 15 years, more than likely a computer like this today would be laughed at in terms of performance and speed, but it was what we had during the day. Okay. Now let's take a look at my screen again, and let's talk about where we've gone to. Okay. Now we talk about the idea of SATA, serial ATA. This is where it gets confusing. Everything that was done in IDE was done in what we call parallel ATA. Okay, so sometimes you actually read it as PATA, P-A-T-A, parallel ATA, and now you have serial ATA. Okay, serial ATA. I don't know why the words sound actually slower to me. Okay, parallel means you're actually sending at the same time, whereas serial is one at a time, right? 1, 2, 3, serialization. Okay, you're actually sending one at a time. But this technology came along later and was faster here, okay, too. And the reason why it's actually better and faster is because the cable itself, too, was better and faster as well. So we actually could send more data on a serial ATA cable, okay, than what the original drives could do, along with the advancement of the speeds of the hard drive and the technology in which the way that they were implemented also helped out, too. Now, the neat thing about these is it didn't have to actually worry about the idea of crosstalk between, hard drives on the same cable. So they actually had a maximum of a single cable and a single hard drive. So this allowed us to be able to actually kind of direct all of the actual bandwidth itself, or the speeds, whatever you want to call it, throughput itself, directly to one drive and not have to worry if it's going to one or the other. Now, in terms of limitation of hard drives, though, that really depended on your computer's ability and the expandability of your computer as well. So I've seen some particular computer motherboards that had as few as 2 places where you could actually connect serial ATA devices to. But Vaughn, I've seen them where it actually had as many as 6. So you could actually have 6 without adding in any additional, expansion cards into your computer. But I've also seen some that had 6, but I've also installed some that actually ended up giving us 4 additional controllers that we could directly attach to an expansion card internally as well. That was one of the heaviest computers I ever worked on because I actually did end up having like 8 hard drives inside of the thing. Okay, so you name it, that thing was heavy. Okay, so that's the idea here. So you could have additional drive controllers as long as you had PCI or PCIe expansions that you could add in there to make that work. So Vaughn, this is a very primitive form of what we call the idea of block storage. Vaughn, we're not really worried about can I store files on them because at itself, right, it is a drive. These volumes are recognizable in terms of how much space we can have. But when we start talking about formatting, now we're starting to talk about the idea of getting users access to be able to store files on them instead. But this is the primary idea of block storage as we get started. Now, Vaughn, that is not the only type of storage that we have as well. Okay. Now, for us, in terms of other storage that we have access to, we want to get into the realm of SCSI. SCSI types of storage actually stands for Small Computer System Interface, which I never remember for the life of me, but the way that it's normally pronounced is SCSI, okay, is what you actually have. Now, this type of connection really harkens back to that parallel ATA again to a point, except for the very fact that it's a little bit different in this way. So remember that with the parallel ATA, we could have a maximum of 2 devices that were on that same cable. Well, with SCSI, we could essentially daisy chain devices together. You could daisy chain up to, 8 devices all together and make it work as well, okay? By doing this, it also sent what we called half duplex communication, okay, between essentially the PC itself and then the idea of the hard drives that it was connected to. Now, in the SCSI terminology, that PC is called the initiator, and the actual storage devices are what we call SCSI targets, is what you actually end up calling them. So even though you daisy chain them together, it actually ended up working as just a regular bus type of topology. And this also meant, just like in bus networking, you had to have a termination at both ends to make it work. So the initiator would be the initial terminator, and then the last device on that SCSI chain, on that SCSI bus, also had to be terminated as well, or the entire bus would actually end up failing for us. Okay. Now, I want to take a look at this technology a little bit more in depth so that we can see it here. All right, so Vaughn, here we're going to actually take a look at this hard drive, or this particular topology here, so that we can see. Let me do it that way. So, okay. So Vaughn, in this way of actually taking a look at it, okay, what has to happen here is simple, is that we have, of course, a SCSI controller that's installed on the initiator itself, and this now also gets a unique identifier, and we'll normally name it at the highest one that it can do. So originally it was actually done 0 through 7. Okay. Then when you come out of that device, when you go to your SCSI drives, they ended up having 2 different connectors on them. One was an attachment to go in, and then the other side also had an attachment to go out. So here at the bottom of the screen, I actually have ins and outs in the way that we can connect them together. And this is what we call daisy chaining these devices together when we get to them, okay? So Vaughn, once we actually set this up and we start connecting them, we always connect the out to the in, the out to the in, and then whatever the last device in line, it gets what we call a terminator at the end of this. That's because without it actually terminating, the signal reflection on the end device would bounce back and cause so much transmission noise that it would actually cause the entire bus to fail. So here, notice, Vaughn, the term initiator, and notice the term target. So the very next device we plug in is device 6, which is the lowest number. So let's say that we had 4 and 5 in here. I just chose not to draw it out, okay? And then we had 3, and then we had 2 and 1, and then the very last device for us on this would be a 0. So that is the device that we would end up plugging that terminator into. Now, once you do that, what you actually create so that the initiator can gain access to these volumes is that you create what we call a LUN, which is a logical unit number. That essentially treats it almost like a RAID array is what it does. So Vaughn, notice that across the 3 drives that I have here, okay, so the first one, ID target 6, 3, and 0, I can essentially create a stripe across, well, here, and we'll call this one LUN 0. So I can actually go across all that, and it doesn't matter how big the stripe is or how much the space is, but I can create that stripe, and it means I don't have to store everything on one of these drives. I can store it across these drives too. Notice LUN 1. I can skip target number 3 if I want to, and just have it stripe across target 6 and target 0. Okay. My last one over here, of course, is LUN 2, and LUN 2 can actually just be on target 6 and target 3. So it doesn't matter how we choose to actually divide up those particular numbers here. That's what happens. Now, the entire thing of this is what we call the entire SCSI bus. Okay. All these elements that I've identified here are important for you as you get ready for the exam as well. Now, I'm not going to tell you that they're always, that they're going to ask you about everything that I've told you, but the terminology that you see here, Vaughn, that's very important. Understand what a LUN is and where it actually goes across. Okay, so notice LUN 0. Notice there's always across drives. Okay, is what you end up seeing here. That is you, like I said, really creating the idea of a stripe across that is what you're doing. Now, on your end, you don't actually know what it's actually doing. You can actually tell it if you want to, hey, just create it across here or there, and that's the way it can actually go. So very important technology for us as we get started, because that's kind of a big one as we take a look here. Now, there is newer technology than the one I just showed you. So there is what they call SCSI Parallel Interface, which is also SPI. And the real big difference here is in the number of drives when it comes down to it. Okay. So remember that the original one that I just showed you here, maximum of 8 devices. Well, what if people start saying, hey, we want this, but we want more than 8 devices? Well, what do you do since the original technology said, nope, maximum of 8? Well, then you actually come up with SPI, which is the SCSI parallel interface. And this is way faster than the original. And this is where the SCSI standards or numbering system got all messed up. And that's because it went from like SCSI to SCSI 2, SCSI 3. Then it went to 320, 640, 160. I mean, the numbers just kind of really got messed up like crazy after a while because everybody started calling them something different.
Yeah, whatever. There's been so many products that they start with a nice sequence and then they totally go on another tangent. And you're like, wait, then now you don't know what is up and what's down anymore.
Yeah, it was very hard to actually keep all that straight. And then somebody tried to unify it, and then of course half the people would agree to it, other people wouldn't agree to call it. So you ended up having this weird system that really didn't work except for people that knew how to identify everything. But with this technology, it actually was faster than the original of up to about 640 megabits per second. So usually the original ran at something like 4 to 16 or something like that, or 10 to 20. It depended on the type of SCSI that you actually implemented. So you name it, you got to actually think about that too. Okay. Also, up to about 16 devices you could implement with the SCSI parallel interface. And then you also had a maximum length that you could run, which was about 25 meters. That's still pretty hefty. If I know that a meter is 3.2 feet or so, about 70, almost 80 feet, if not more than that. Okay. So, because let's see, 3 times 25, that would be 75. And then
25 meters is 82
82 feet. So, see, my math is almost working. Okay. So, it's one of those things. Okay. So, that's actually kind of the way that it ended up going. Now, even though this was good technology, it wasn't the latest advancement of the technology as well. Okay. So, when we start talking about that, SCSI itself also could actually go into what we called SAS or SAS. That's the way that you normally heard it. That stands for Serial Attached SCSI. Now, this one said, look, serial ATA works so well, right? And it didn't kind of put multiple devices on one bus altogether. So what if we did the same thing with SCSI? Well, Serial Attached SCSI does point-to-point interfaces between the initiator and the targets. So now you actually have a single, the term that the production team likes to use on here, a single home run, okay, is what they call it, right? A single cable that attaches to the device, the drive that you want, going all the way back to the controller or to the computer that you want as well. Faster, but it also limits the distance that you have with the internal hard drives and everything else too. So this is actually one of those that's very popular, especially when it comes to SANs and to the idea of NASs as well. Still attached to SCSIs have actually been out there quite a bit. All right, so Vaughn, that's kind of the big ones as far as just that one, okay? Now, the two main protocols, and we're not going to get into iSCSI too much, and there's a reason behind that, okay? But we are going to talk about it briefly here, Vaughn, okay? So with SCSI, there's not only all the stuff that we talked about, right? The idea of just a simple SCSI, the SCSI parallel interface, as well as the serial attached SCSI. The one that is most used today among enterprises and corporations is what we call iSCSI. iSCSI is very, very popular, and the reason why its popularity gained and is where it is today is because, well, the other technology that we use for networking and block storage is insanely expensive. Unless it's really come down in price, it's still insanely expensive. iSCSI, though, is not insanely expensive, and that's because it doesn't use proprietary technology to give you what it can do in terms of what fiber channel can give you. Okay. Now, the limitation, though, is simple, is that you have to operate at whatever speed your network is operating at. So there's limitations to that, right? So even on a gigabit link, it sounds super fast, and it is super fast, but it's not as fast as something you could get from fiber channel, okay? So with internet SCSI, for us, what this allows us to do is to be able to run that SAN, but instead of actually using fiber channel connections and nodes and all this other stuff here, you actually end up using, well, TCP, and you end up, of course, transporting the data using IP instead. And it does work, but it is also still fickle in the same way that IP networks are. You got to worry about things like your broadcast domain. Okay, how big is your broadcast domain? Will an iSCSI device also get affected by broadcast? Yes. Okay, you got to realize that all that is going to happen in that way. So you still have that even with fiber channel, but it's a lot less because there's not that many fiber channel devices. But an IP network, there's a ton, okay, that you have to worry about. So it does work. It does actually help us out quite a bit. Now, the setup to something like iSCSI, it's not super complex as long as you actually get the identifier correct to the target that you are trying to hit. That's kind of the hardest aspect of it, because it's not like just go to SCSI 1. Okay? It usually has a fairly long identifier that you have to come up with, and then make sure that the operating system that you're using to manage it can read the identifier correctly the way that you need it to. Okay? Once you get that down, it's just simply typing it into the space that needs to go, and it finds the SCSI target, and then you're off and you're connected and you're ready to go. Okay? So relatively easy. So easy that you can actually even do this inside of a virtualized testing environment where you can set up a virtual NAS and set up a SCSI target, a nice SCSI target. So like in Windows Server 2012, I know. Okay, I don't know if 2016. I haven't actually checked on it, but there's actually a nice SCSI initiator in there that you can actually connect and be able to find a nice SCSI target fairly easily. So all that technology is already built into the software that you don't have to worry. So that's how popular it got, at least at one point, to be able to do this. All right, so Vaughn, there is that other big channel, technology I want to talk about, which is fiber channel. But looking at the clock, I really only have about 5 minutes left or so. That's just not enough for us to actually end up talking about the idea of fiber channel here. Let's go ahead and end just a little bit early, and we'll pick up on fiber channel, and that should help us to cover the rest of what we need to at least begin to understand about the idea of block storage access.
All right, Ronnie, sounds like a great plan. So we're going to go ahead and skedoodle on out of here. Let's go ahead and sign off for IT Pro TV. I've been your host, Vaughn Smith.
And I'm Ronnie Wong.
And we will see you soon.
Thank you for watching IT Pro TV.